In this problem, we want to make this molecule a trans alkene from the other alkene here, but we have less carbon. So first step, analyzing the structure and see the changes in the skeleton. So how many more carbons do I have? So I have 3 more carbons, so I need to add something so that I can make that larger. So how do I add carbons to that chain and add that fragment, something like that? With first, one strategy could be using something that we have used before, which is having a terminal alkyne, and then we treat the say with sodium amide, and we follow with another, say, some alkyl chain. Let's call that R1 and this R2 and some halides so that we have a group that is a good living group. So that would be the schema, the idea of an alkylation reaction. But if I want to use, if I want to add 3 carbons, then a good idea will be using at some point propine, because if I have propine, I will have a terminal alkyne, and I will have the 3 carbons that I need to add, but I need to make that an alkyl halide, so that is completing the bonds, right? So I need to make, if I have this part to add the 3 carbons, I need to make now the alkyl halide from this. And so I want to make it a primary, so that is a good substrate for the alkylation. So how do I do that? Well, if I want to have, say, a bromine terminal, notice that it would be an anti-Markovnikov hydrohalogenation, because at the end of the day, I want to have the bromine here. So I need to use, for example, HBr with peroxide. That way, then, I will have the halide with the anti-Markovnikov product. So here is what I have. So again, you're adding we're adding the H here, so anti-Markovnikov, and the bromine here. So next step will be, I need to make in another, say, reaction vessel. I'm going to make that and have it react with sodium amide. So let's do that. So I'm going to have that react with sodium amide. When I'm doing that, I will be making, say, this I'm just drawing that with no H's, right? It's the same, just removing the hydrogen. So what I'm doing here is then the SN2 reaction. Now we'll have my attack here. And now I am adding 3 carbons to the chain. So let's draw what is results at the end of the reaction. Here we will have the following. So this part will draw the same. And now here I will have the 1, 2, and 3, and 1 more carbon. So how far are we from that? Not that far. What do we need to do if I want the trans stereoisomer here? So I need to use one condition to is partial hydrogenation that gives me that stereochemistry. And this is using sodium and ammonia. Remember that condition will give you the trans alkene. So I'm going all the way over here, and that's my target molecule. Okay, so recap. What do we do when we have a problem like that? The first step was analyzing the change in the number of carbons in the compound here. So I notice that I have added 3. And I know already that a strategy, which is using alkylation of terminal alkynes. So strategy-wise was, okay, I need to have a terminal alkyne and make it react with an alkyl bromide. And so if I need to add 3 carbons to the chain, that terminal alkyne will have 3 carbons. These are the 3 carbons I need. But then that's one part, adding that. I need to make the alkyl bromide And I will make it here by doing the anti-Markovnikov hydrohalogenation. When I do that, next step is, say, in another reaction, I'm going to create the anion here that will serve as nucleophile. Now I'm putting these two together in my SN2 reaction. That's the SN2, right? The final step is ensuring that we have the trans stereochemistry, and that is using sodium and ammonia.